Good morning, everyone. This topic is going to regarding the electric field. Physicists did not like the concept of actions at a distance, that is, force that was caused by an object along the long distance away. They preferred to think the object producing a field and another object interacting with that field. Thus, rather than they like it to think. Electric field is defined as the force acting on a test particle divided by the charge of the test particle. E equal to F by Q. Diagram shows the electric field E, the force F, and the distance R. The charge incurred is Q naught. Thus, electric field from a single charge is E equal to 1 by 4 pi epsilon naught Q by R square or vector. Electric field of a single charge. The electric field is defined everywhere, even if there is no test charge is not there. Electric field from a test particle. Electric field from isolated charge interactive. Charge when an electric field is incurred over a charge, Q naught E is an electric field, R is the distance. Charged particles in electric field. Using the field to determine the force. For a positive charge, it is moving towards right side, F equal to QE. For a negative charge, it moving left side, F equal to QE. The magnitude is same, but direction is different, opposite direction. Electric field is a vector field. The electric field is one example of a vector field. A field, vector or scalar, it is defined everywhere. A vector field has direction as well as size. The electric field has units of newtons per coulomb. Representation of an electric field. It would be difficult to represent the electric field by drawing vectors whose directions was the direction of the field and whose length was the size of the field everywhere. The diagram shows the electric field. In the representation of an electric field, instead we choose to represent the electric field with lines whose direction indicates the direction of field. Notice that as we move away from the charge, the density of line charge decreases. These are called electric field lines. Drawing electric field lines, the lines must begin on positive charge or infinity. The lines must end on negative charge or infinity. The number of lines leaving at a positive charge or appearing a negative charge is proportional to the magnitude of the charge. Electric field lines cannot cross. This diagram shows the electric field moving outwards direction past a positive charge. Second diagram shows the electric field lines moving towards the negative charge. The third diagram shows how the electric field move from the positive charge and moving through the negative charge. Field is not zero here. Field is zero at midpoint. Field lines for a conductor. Field lines for a conductor is based upon the charge distributed over the conductor. Positive charge is moving outward or negative charge is moving towards the directions based on the positive or negative charge of the conductor. Drawing electric field lines, for example, from the electric field vectors to the field lines from all angles, field lines for representations is represent from the positive charge to negative charge. The electric field, the number of density field lines is rho equal to number of lines divided by A, rho equal to n by 4 pi r square. Since n lines is proportional to q, rho equal to q by 4 pi r square. We know that modulus of E equal to 1 by 4 pi epsilon naught q by r square. E is proportional to rho. Thank you.